Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard. This is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, let's talk about something priceless, timestamps, time zones, and so on.
I like the priceless reference, that's great. Yeah, so this is another listener request from quite a while ago. Yes, sorry, you were going to say.
You noticed how I wanted to interrupt you, but referring to also to our idea that I should interrupt less often. So I have another reference. Let's keep this episode short. It's about time.
Oh, nice.
Right.
It's about time.
Yeah, it will be short. Why not?
Yeah, it's a great suggestion, great request. It's one of our earliest requests, actually. So it was specifically about timestamps in general and time math, or arithmetic maybe. So yeah, it's quite broad, but also I guess we can take it in a few different directions. Where did you want to start?
Let's start with the idea that timestamp with time zone should be always preferred over regular timestamp without time zone. What do you think about this idea?
So I guess we're jumping into the specific data types here on how we're storing these in the database. And there's a couple that Postgres lets you use, timestamp and timestamp TZ. So timestamp without time zone and timestamp with time zone. I think it's quite a confusing name. And the reference I normally point people to is the Postgres wiki. They've got an excellent list that's quite aggressively titled called "Don't Do This." But one of it's aggressively titled, but it also includes information on when it might make sense. What are the exceptions? But one of the ones that has very few exceptions is you probably always want timestamp TZ when you're storing these.
Right, and since it's a couple of more letters, it's easier to write just timestamp and then realize that maybe it was not the best choice. And but I would like to mention that usually, at least it's my perception, usually you think about timestamps as something bigger than the regular numbers, integers, and especially if it's with something else like time zone, right? It's maybe even bigger. If you think about storage, you maybe think, okay, I maybe need to use regular numbers, and of course I don't want to bump into the limit of 4-byte integer, so I will choose 8-byte integer, right? So int 8 or big int. And then you realize that regular timestamp is also 8 bytes. And then you realize that timestamp with time zone is also 8 bytes. They are all 8 bytes. So the choice is should not be based on storage here. Big int, timestamp, or timestamp TZ. Timestamp with time zone. Timestamp TZ is Postgresism because it's standard way, SQL standard way data type is timestamp with time zone for 4 words. So I personally try to encourage all engineers usually to by default choose timestamp TZ, explaining that there is no storage benefits of regular timestamp. Right?
Yeah, exactly. And there's loads of benefits of the timestamp TZ. So, for example, if you're doing, I guess we'll go on to arithmetic later, but if we're calculating the difference between a timestamp, at least in the UK, I think in the US, a lot of other countries observe daylight savings. If we're doing arithmetic between two timestamps and we're crossing a boundary like a daylight savings boundary, we won't get the right answer we're more likely to have issues if we're using timestamp without time zone. So Postgres can handle all of that stuff, that complicated stuff. The reasons people talk about times being difficult, that can all be handled by Postgres if we're telling it that this is. And I guess should we mention the name? It's not the with time zone. I think it puts people off and is confusing. I guess from the wiki I stole their description that timestamp is a bit like a photograph of a calendar and a clock, but you have no context. And a timestamp with time zone, it knows, or firstly it can convert that, or it does convert that to UTC, and it has the context of a point in time, so it knows when that is rather than what it is.
Right, maybe. And the resulting value will depend on the context, which you can change in any session. So one session sees one value, final value, another session sees another value, just because they are sitting in different time zones. So that's why it's more flexible and convenient and so on. Right.
Yeah. So you've already touched on the storage efficiency. Are there any other kind of performance-related things that you want to talk about?
Actually, good question. I don't know. I never thought about like timestamp. Is that less performant? I never tried to measure it. It's a good question, but I doubt there is a big difference here.
Based on my understanding of how they're stored, I don't see how there could be. But yeah, let us know if you know differently.
Yeah, you need, of course, you need to do some arithmetic operation in runtime if you have with time zone. But I don't know. I think it's very small. Of course, an interesting exercise to compare and see some differences. Maybe there are already these exercises in some blog posts. I don't know. But I wanted to mention a dangerous part of SQL standard, which is an operator called add time zone. It's very dangerous. It's the ugliest parts, the ugliest corners of this huge building called SQL standard. So it can be very tricky if you don't know there is danger. It's like nulls, right? So nulls are dangerous and add time zone is dangerous. If you check how it works and what is resulting data type for each value, for timestamp it will produce timestamp at time zone. For timestamp at time zone it will produce timestamp. If you take timestamp without time zone and say add time zone, you will have timestamp at some time zone. If you take a timestamp at some time zone and say at time zone, it will produce timestamp without time zone. And this is from standard, wow, as I remember. So if you go there, just open the reference, right, and do any movements with reference. No movements without it, right? just a warning for you. So. Performance, I didn't think we will discuss a lot of performance questions. Maybe just the idea that, of course, it's perfectly indexable, both timestamp and timestamp TZ. If you have such columns, you can index them. But I had several times, I had a case in my engineering practice when I needed to have something like age. By the way, there is such function age, which you can give either two timestamps to it and it will just calculate interval. There is interval time, data type, it's whole new world, time ranges, intervals, and so on. So you can give 2 points in time and it will calculate difference. Or you can just give one timestamp and it will compare it with current time. Right, and it will be just a regular like age. So you say like my birthday is this, and it gives you age as interval. But I wanted to store this interval, and then I wanted to index it several times. And always it was a question how to do it, because you cannot have an index on something which involves time zone, because it's not it's volatile, right? It depends on the context on your session. If you change time zone in session, saying say time zone to, I don't know, like Europe, Berlin or something like this. In this case, you will, or new time zone, by the way, Europe, Kiev. There is new time zone. Yeah, but it's not a benefit from Postgres. Coming from Postgres itself, it's lower level. It's, libraries. I don't know libraries, but it's coming from underlying software. So if you set it in session, the value will be different and probably interval will be different. So you cannot index it easily. If you, for example, you want to index expression, you store time zone, but you want to index to support fast lookups based on age, And my workaround was I switched to different approach to store time. Based on Unix timestamps and so on, I just said, okay, but Unix timestamps are limited on one end, on the beginning. 1970, maybe January 1st, I don't remember, but some point in time in 1970. And then it's just a number of seconds passed. The Unix timestamp is number of seconds passed since then. By the way, I wish in Postgres it would be easier to convert from timestamp to Unix timestamp back and forth. It's quite an expression. You need always to Google it. The Stack Overflow or something will help you, right? It's memorize it. It takes like 5 years of practicing constantly to write it blindly. So Unix timestamps are limited on one end. They are technically limited because of capacity of integers on another end. But my idea was, okay, I say our software will exist only till 2050. So we have some line. And we can measure, we can see progress, and we can have ranges, and this is very stable already. Of course, I lose time zone benefits and flexibility, convenience, but I'm on perfect range of numbers. We live. This is our universe, right? And we deal with only with points on this range, and anything you do there, you can index any expression, anything. So this was my approach as a workaround. Maybe there are other approaches to deal with age and still build an index on some expression involving age. But usually it's a trick, and people bump into it and think, oh, what to do? So what else? What else do you have in mind related to timestamps?
So, well, quickly while we're because I don't think we'll come back to performance, I guess this is a good time to mention that obviously B-tree indexes work nicely for things that are sorted like this, but we've also done an episode on Brin indexes. So timestamps are probably the most common use of Brin indexes that I've seen. I think that's what they're mostly used for in the wild. So yeah, refer back to that maybe if that's of interest. You mentioned intervals. Should we cover those now?
Yeah, but one more comment about indexes. There is a very popular type of index called GIN, right? And there is a big problem that usually you have a full text search and you want to order by some number or timestamp. And to solve this, there is an index called RAM. It's not present, I think, on RDS. I remember I personally asked them to consider it. But the problem with it, usually index size is huge. I know Supabase, by the way, includes it, RAM. I wonder what's experience there, because my experience was, I considered it several times, and every time I considered it, RAM was huge. So idea of RAM is you have GIN plus you have knowledge about some timestamp, or integer 8. They originally developed only timestamp support, but I asked also to add integer 8. They did. It was many years ago. So now it has both options. So RAM is like GIN extended with some timestamp. So now you can have in single index scan, you can have almost single index scan, but you can have both operations covered, full text search and order by some timestamp, which is perfect for like search in some comments, for example. You always usually want fresh comments coming first, right? So it's a very great idea. I wish Postgres it would be more include to core contribution modules, maybe contrib modules, but it's not. And it has issues with size and affecting performance and so on. But idea is great, and the goal is great. So also related to timestamps. So it's interesting that it injects timestamp to GIN, and it becomes RAM. Very strange, right?
At the risk of going off topic, I know gin is not named after the alcohol, and rum I think is a play on that it is. But there's also I only read briefly about it, but an index type called vodka
Yeah,
as
well,
well.
it was only like in development and never reached some like production stage. But RAM is quite like it's quite finished, and you can consider it. But I'm just saying that my personal experience was not perfect. But it doesn't mean that there is no need. Need is huge. Like usually we end up having two types of plans. Like either Postgres either chooses to use full text search and then order by in memory, or it chooses to walk along primary key or index on timestamp TZ, and then apply filtering in memory for full text search, which both are not perfect paths, right? So like the problem is obvious and it's not fully solved. But with RAM it's solved again. Like maybe you should try it. So you mentioned time ranges or intervals. Intervals first, right?
Yeah.
Yeah. So we should also mention that there is date and there is time. Right. And when some engineer creates something, some column, and calling this column time, but it's timestamp, it breaks my mind always. Because like, okay, this framework of naming in Postgres, I like adapted it already, and I cannot see time when it's timestamp. No, it's not time. It also includes dates. Like at least let's say date time. By the way, maybe standard also has date time. I remember other database systems have date time as data type. So there is date, there is time. When we combine them, it's timestamp, right? Like it's full thing. Yeah. But we can have also a column of type date, right? Or of type time. Why not?
Yeah, but I think date's difficult because of the boundaries, right? Like, what does like midnight and time? Like, I think it's tricky. I think personally, I would stick to timestamps in general. But maybe I'm missing.
Well, it's two times better in terms of performance or in terms of storage because it's 4 bytes. Right, so you can save some bytes if you want, but you should remember, of course, about alignment padding. If you place date and then integer 8, no benefits because 4 bytes will be filled by zeros. So you should combine with our 4-byte column. I don't use it often, honestly. So I agree with you here, but also there is time, and sometimes we technically we can use timestamp as time, saying. Like you can use timestamp instead of date, taking some time of day, but also you will start thinking, okay, if it's time with time zone, it's another date can be different depending on time zone. So it's becoming tricky. So probably this is where you probably will try to choose timestamp without time zone, just to be concrete. Okay, it's UTC. I consider it as UTC. This is our date. That's it. Again. Depends, right? But if you think about time, technically you can use timestamp just like choosing some date always, like January 1st, something, right? And I don't know. But it's not, it looks ugly, right? So time sometimes is needed.
Yeah, so there's time with time zone as well, and time. And there's a really good note in the documentation and on that wiki page I mentioned earlier to say basically, I think there's no exception. They couldn't think of a single exception where you would want time with time zone. They go into some details as to why why that makes sense. But time on its own makes sense in terms of like a photo of a clock, or like if you're a calendar application or a to-do list application, and you want like let's say you want to go walk your dogs at 9 a.m. every day, you want that to be 9 a.m. in summer, and maybe you want that to be 9 a.m. in winter. But it's the time of day, not a time in with a date. And so I think I can see more uses for that, and I probably would store it as time because it's not time.
Yeah, maybe. Right? Yeah. Also worth mentioning, they all both of timestamps and both of times they have precision. Modifier, right? So you can, in parentheses, you can say, I don't want microseconds. Just put a 0 there and that's it. Also convenient. I use it sometimes because like it becomes easier to have predictable output without. Just now converted to timestamp and 0 in parentheses gives you timestamp with seconds, but without milliseconds.
The wiki advises against it. I think because it rounds rather than truncates.
Okay.
So it's possible to round to a time in the future, which might not be what you want. But yeah, it's interesting. I think they recommend truncate instead of date trunc as a function. Or time, I can't remember.
Date trunc will give you, it will give you, you can take seconds, right. So and everything else will be filled like with zeros, right? Or it just can be if you want, for example, to take only date from, like my small trick, usually if I have timestamps, I want only date, for example, to then aggregate and have some report. I use left 10, left timestamp value, comma 10. It gives you date usually, right? It's stable because we have 4 digits for year and divider and so on and so on. So left is much faster, but of course date trunc day, for example, also works. So it depends. It depends. But left function, I love it. It's of course it's to work with text, but it's much shorter sometimes. So but interesting that time is a regular time without time zone. It's also 8 bytes, but with time zone it's 12 bytes.
Yeah, I didn't understand that. How could it be more?
Surprise. I don't know why, but surprise. So that's why I usually try to stick with timestamps as long as I can, and only then I go to less, for me, to less popular data types. But interval is even worse. It's 16 bytes.
So why is that? Is it because it's storing 2 timestamps?
Actually, I don't know. Question to our listeners: leave a comment, right? If you're watching at YouTube. Leave a comment, please. Explain why. It's an interesting question. Well, interesting, but not like if you store it or you care, but you don't have a lot of good options. So interval is very good. It's very powerful and very flexible, very convenient. I use it a lot, including for DBA practice. For example, you want to understand how long your transaction or statement lasts, or when last state change happened, and you want something like age. You will have you can use minus operator, and you will have interval as output. By the way, question to you: what would you use if you select from pgStat activity to see when transaction age, for example? How would you use it? So there is an exact start, XACT underscore start column, and there is of course current timestamp. So many people use now function minus exact start, but it's quite wrong. Now function is very good in terms of performance because it gets timestamp only once in the beginning of your transaction. So your select is also a transaction, right? So now is calculated only in the beginning, but pgStat activity, it's not a normal table, and values are constantly shifting. And if it's quite big, while we read it, it's not stable. We don't have snapshot there, so you will have shifted values. You probably will end up with negative age values, negative intervals. So what you should use is less performant function, because it will calculate current timestamp for each row. It's called clock timestamp. So clock timestamp minus exact start and transaction start, right? So, and in this case, you won't have negative values, which is good, right? So, small trick. And sometimes it's also worth remembering that now it's like boom, and you have it for all, but maybe it's not what you want. Okay, good. Anything else we wanted to cover?
I only had one more, which is only tangentially related. but I heard some good advice a while back that if you are adding a column that's Boolean, that you're planning to use a Boolean for, consider using a timestamp. So I think the good cases that I've heard for this are things like unsubscribed at, or it's basically sometimes you don't necessarily need it for the first set of features, but it can be incredibly useful down the line.
Yeah, I also use this approach. Yeah, but you should remember storage overhead, of course, because Boolean, of course, it's not 1 bit; it's 1 byte. It's you already are 8 times worse than you could be. You can be like most storage efficient approach would be like spend 1 byte for 8 checkboxes, right, and then work with bit operations. But okay, if you have Boolean column, it's 1 byte. Of course, if you have 8 of them, they will occupy 8 bytes. It's good. If you have Boolean and then timestamp or integer 8, you will have 7 bytes lost anyway. But in this case, of course, switching to timestamp won't make any difference in terms of storage overhead, right?
Yeah, but it was more you're right in terms of storage, but it's more of like I think it's like quite a good thinking exercise when you're designing a new feature, just to think, could there be benefits down the line of storing this in a different format, and that it's made me think
when you are designing, you think about if you need to remember when checkboxes were pressed or clicked or checked, right? So yeah, it's depends on the application, of course. Oh, I wanted to mention these all balls. You know all balls? What is all balls?
Oh yes, all the time, the 000.
000 time, UTC, right? So yeah, it's kind of like interesting joke maybe, right? So, but
it's committed, right? Like it works.
Of course, you can say. Oh, by the way, how to get, for example, interval. How to get current time minus 1 day, like now, minus. I write 1 day in commas, not in commas, in quotes, single quotes, and then convert it to interval, and that's it. Or say minus interval and then string literal 1 day. It works perfectly. Or 1 hour, it works. But also there is so wall balls. It's like also in single quotes. You convert it to time and have this time. But like it's kind of a joke. But what is more useful is infinity, minus infinity and plus infinity, right? This is useful. You can have a timestamp infinity, and I can imagine very good use cases when it's like very, very helpful to develop good application behavior.
That's a really good point. So I feel like I've mentioned it too many times already, but that wiki article I think also includes not using it, or between probably not being what you want when it comes to timestamps, and you probably want less than one and greater than another, and that's where I've seen infinity used most. Yeah. So you might want to be selecting all times from sometime in the future to positive infinity, or from sometime in the past but less than minus infinity.
Right. Agree. Good. So what else? Or that's it? We wanted to keep it short.
That's all I had.
Yeah. Then let's wrap up and call it a day, right?
Yeah, fabulous. Thanks so much. Thanks everyone for listening. Keep the suggestions coming, and see you next week.
Thank you. Bye-bye.